Hi, welcome to my video on the diagonals of a right cylinder. The diagonal of a right cylinder is a segment drawn from a point on the circumference on the top, which is F, through a point in the middle of the inner space, which is P, that point is right in the middle, at the end, ending at the end of the diameter up in the bottom. So this is the diameter that's on the bottom. So the diagonal of a right cylinder leaves F and goes down through a point in the middle to the end of the diameter. And notice that this is the height, and this height is now perpendicular to this diameter. So that's the height of the cylinder, and we form a right triangle. So we have a radius is OB, and AB is the diameter, and we have a perpendicular. And this diagonal, this one, is the longest one. There are others, but this is the longest one passing through the middle. To show you that, I've made up a diagram made up of a cylinder, and you can see it's similar to the one above. F is this point right here, and I place it down, and on the bottom you can see the diameter moving through. I'm going to use this green to indicate the diagonal goes from A on the bottom to F. So there is the diagonal, and there are infinitely many more, because if you take this point right here and go to another diameter, then that could be the longest one. Or if you take this point right here on the top, it could go down to there. So there are many diagonals. There's an infinite number of diagonals in a cylinder. There's an infinite number of diagonals in any right cylinder. So we could leave here and go down to there. We could leave here and go down to here. We could leave this one and go down to here. There's infinitely, but all these diagonals, which are the longest ones, will pass to this point at the center. Okay, we have a little problem here. Find the length of the longest diagonal of the cylinder. So we have a cylinder. The radius is 3, so R is 3, and the height is H. Height is 8. So if we have a radius of 3, we have to find the length of the longest diagonal. So the longest diagonal, this is one of them, going from the top here, going to the middle to this point. That means if you draw the radius of 3 and you extend it further, then that's a 3. So that means the diameter is twice the radius. So that's diameter is 6. So that's 6 long right there. And the height is 8, which is this length of this segment. And we have a right angle. That means we have a Pythagorean. So this diagonal D is set up in the sides of a right triangle, D, 8, and 6. So we have C squared equals A squared plus B squared, which is the Pythagorean property in a right triangle. C is opposite the right angle, so that's your D. That's your hypotenuse. 6 is A, 8 is B. D squared is 36 plus 64. D squared, 36 and 64 is 100. D is the square root of 100, so D equals 10. So the length of the longest diagonal is 10 feet in this particular cylinder. Okay, let's continue. Let's do some practice. Some practice in my videos means pause the video and work out the question. Then play it back to see if you got it right. And do that for each question. and that helps you to see if you understand what you're doing. Find the length of the longest diagonal of this cylinder. Well, the longest diagonal, again, I always draw this one going up here. And I have a right angle with the height comes down, hits the bottom, and this is the diameter forming the right triangle, 3 sides with a right angle. And OA is 4. That means that O, let's call it F if you want, is 4. That means that the total length of this side of the triangle is 8. So we have a triangle 8 and 15, and we want the length of the longest diagonal. D is the diagonal. Again, we got C squared is A squared plus B squared, the Pythagorean property. And we have C is the hypotenuse opposite the right angle, so that's the D. 8 is the A, 15 is the B, and we take our time, and 8 squared is 64. 15 squared is 15 times 15 is 225. D squared, that adds up to 289. And D is the square root of 289. So D equals 17. And the units are, so the length of the longest diagonal is 17 yards. Let's go on to number 2. Number 2, find the circumference of the base of the cylinder to the nearest tenth of a millimeter if the height is 24 millimeters and the longest diagonal is 26 millimeters. So let's draw a little cylinder to keep everything in perspective here. To see, this is the cylinder. It says we have to find a circumference. The circumference denoted by D. So let's say that's my question mark. And we're given the height. We know the height is 24. And we're given the longest diagonal is 26. So we got our cylinder drawn. We have our height of 24. The longest diagonal, again, I always draw this one going from top to bottom here. That's 26. And we have a right angle, so it says circumference. So the circumference is C equals 2 pi r. So in order to get the circumference, I need the radius. So if I have a right triangle, if I draw the diameter here, and I have a right angle, then this is, I call it x. I have a Pythagorean property again. C squared is A squared plus B squared. And opposite the right angle is C, which is the 26, which is the hypotenuse. X is the A, and 24 is the B. And 26 squared is 676, x squared. 24 squared is 576. So 676 subtract 576. Notice I'm moving the 576 to the left side to make it a negative. We subtract and get 100. So 100 equals x squared. So x squared equals 100, just to rewrite it. X equals the square root of 100. X equals 10. And that means that our diameter is 10 units, or 10 millimeters. That means the radius is 5 millimeters. Okay, so that means we can go on to find the circumference. 2 times 3.14, which is pi, and the radius, which is 5. And 2 times 5 is 10, so 10 times that, move the decimal one place to the right, and we have 31.4 millimeters for the circumference of the right cylinder. Okay, number 3. Find the lateral area of a right cylinder to the nearest tenth of a square foot if the longest diagonal is 15 and the radius is 4.5. So we have to find what we call the lateral area. And the lateral area is made up of circumference times the height, which is circumference is 2 pi r(h). And to explain that, if you take the cylinder, if we have a cylinder, which I will draw for you. There's the cylinder, and the longest diagonal is 15. Okay, the radius is 4.5. And again, we have a right angle. That's the height. And if the radius is, we have a radius of 4.5, that means we have a diameter which is twice the radius, which is 9. So 4.5 multiplied by 2 is 9. So it's 9 meters. And so that means that the diameter is 9. So it's 4.5. Add on 4.5 or 4.5 doubles. So there's the 9. Again, we have a Pythagorean on the go here. But we need the lateral area. And the lateral area, we need the radius. We have the height. So we have to do the Pythagorean property to get the height. Again, you can see that I'm always emphasizing. And there's the right angle. So there's the hypotenuse 15. So that's opposite. That's my C. C is 15. I always fill in my hypotenuse first. May I know it, or I'm trying to find it. And 9 is the A, and B is the height. 15 squared is 225. 9 squared is 81. 8 squared, 225. Subtract 81. And I get 144. So H is the square root of 144. And this H is 12. And that's 12 meters. So that's my height of 12. So that means if the lateral area is 2 pi r(h), pi is 3.14. My radius is 4.5 given. And the height I just found to be 12. When you multiply all that out, you get 339.12. And again, it's the lateral areas, so square meters. We want it to the nearest tenth. So the answer is the nearest tenth is right there. So that's a 0. This number is less than 5. So this one don't change. So it's 339.1 square meters to the nearest tenth is the lateral area. And again, memorize the formulas, keeping track. Notice that, just to emphasize, if you take the cylinder and cut it down the side, it unfolds like this. It rolls out to form a rectangle. And so that circumference right there is this distance right here. So that's my circumference, and that's the height going down here. And that's why the formula for the lateral area of a cylinder is CH, which is 2 pi r(h). Good way. So notice I'm understanding what I'm doing, so if I forget, everything fits in place. Let's continue to do the last property. Again, practice means pause the video, see if you can work out this problem, and play it back when you get it done, see if you got the right answer. Find the surface area of a right cylinder if the lateral area is 376.8 square inches and the height is 15. So again, we find the surface area. Okay. And it says the lateral area is 376.8 square inches. And we have a height of 15. So if we want the surface area is made up of the base area plus the lateral area. And in a cylinder which looks like this, here's the cylinder. A cylinder has 2 circles, so that's 2 times pi r squared plus its lateral area is the area of the side. But we don't have to write the formula for the lateral area. We could go 2 pi RH, because just then, in the previous problem, number 3, we discovered that was C times H, and C is the circumference. But we already have the lateral area, so part of the problem is done for us. We just need to get the base area. And how do we do it? Well, we have a height of 15. We have a lateral area, which is, the lateral area is 2 pi RH. So that means 376.8 equals 2 pi r. And the height is 15. So in this lateral area formula, we have the lateral area, we have the radius, we know what pi is. So if you multiply 3 by 3.14 by 15, you will come up with 94.2 for 2 pi times 15 will give you 94.2. Divide both sides by 94.2. Because that's a multiplication, we divide both sides. That gives us r, cancels out. And 376.8 divided by 94.2 gives us 4. So the radius is 4. So we want the base area. So the base area is a circle. And the area of a circle is pi r squared. So it's 3.14 times, the radius is 4 squared. And that's 3.14 times 16. 4 times 4 is 16. And that gives us 50.24. And now we got the area of one circle. We got 2 of them. So this surface area is the base area plus the lateral area. And we have 2 circles, so it's 50.24 for 1. Lateral area is 376.8. Multiply by 2 and I get 100.48. Add on 376.8 and that gives us a total of 477.28. We're not asked to round it off, so we leave it like that. And it's area, so the units is inches. So this is area, so that's square inches. This is a length, so that's just inches. And this is area, so that's square inches. So 477.28 square inches is the surface area of that right cylinder. Again, a little bit, I'm always varying it, switching it around. This time I gave it a lateral area. That led you to getting the radius because you knew the height. So you're working a little bit different. If you like my video, click on the like button, click on the subscribe button. And if you're a subscriber, click on the notification bell because there's more videos coming your way. Write a comment on my video if you wish. And visit my math website, www.mathfullyexplained.com. There you'll find information on me, the videos, my teaching style I'm going to use to help you learn your math. And the section on content gives you all the topics that's going to be on my channel and number of videos. And there's more to come. More to come throughout your high school. Hope you enjoyed my video. Thank you very much. Bye-bye.